Alright, this video is going to teach you how to do a dihybrid Punnett square using two monohybrid Punnett squares to find your ratios. Our question that we're going to work through as our example today is the one right here. Two pea plants are heterozygous for round yellow seeds that are crossed. First, you need to always figure out what the parent genotypes are. This problem is asking you to find the genotype and phenotype ratios of the offspring. Now, each parent is exactly the same, and they are heterozygous for both traits. Remember, heterozygous means you have one dominant allele and one recessive allele. We also know, it tells us here, that round and yellow are the dominant traits, and wrinkled and green are the recessive traits. So we're going to use R for round and Y for yellow as our letters that we'll be using. So the parent combination for the genotypes are going to be big R, little r, because it's heterozygous, and big Y, little y. When you're doing dihybrids, you write both of the genotypes together. The other parent is the same, so big R, big Y, little y. So there are two genotypes. Now, step 2, now we can start setting up our Punnett squares. To do this, we're going to set up two different Punnett squares, one for each trait. So one for the round and one for the color of the seed. So for the big R, little r, we will put one parent genotype here, so big R, and the other allele here. And we'll move it up a little. And then we'll do the same over here for the second parent. They have one big R they can give, then they have one little r they can give. Then we fill in our Punnett square with the correct genotypes and letters. And then we would do the same over here, but with the yellow for the seed color. So big Y, up, and little y. Make sure as you're doing your Punnett squares, your letters look different, the capitals from the lower cases. And again, we fill in with the correct genotypes for the possible offspring. Once you have figured out and filled in your Punnett squares, then we can start looking at the ratios. And we're going to start with the phenotype ratio. It's a little simpler for this type of problem. And then I'll talk about how you would do the genotype ratio. So first you want to do is look at each Punnett square individually and figure out the ratios. So here, if I'm doing the phenotype ratios, anything with one big R will be round. And so I have 3 out of my 4 are going to be round, and 1 out of the 4 is going to be wrinkled. On this side, for this Punnett square, 3 out of the 4 will be yellow, because these 3 have a dominant allele, and 1 out of the 4 will be green. Once you've determined that, now what we can do is we can figure out the different combinations, and you then just multiply together the probability of each phenotype from the two different Punnett squares. So for round and yellow is 3 out of 4 chance to be round. You multiply that, so times the probability of being yellow, which is also 3 out of 4. And we get a 9 divided by 16, 9 out of 16 chance that we would have round and yellow. For round and green, we do the same thing. Round again was 3 out of 4. Multiply that with a chance of being green, which in this case was just 1 out of 4. And here we get a 3 over 16. Wrinkled and yellow, 1 out of 4 will be wrinkled, and yellow is 3 out of 4, giving us again a 3 out of 16. And then the last one, the wrinkled and green, only 1 out of 4 chance of being wrinkled and 1 out of 4 chance of being green gives you that 1 out of 16. You can leave these as fractions, or what you can do is then put those into one large ratio where you would have 9, and because they all have the same denominator, that's 16, we can just take the top number, 9, round, and you should always label round, and let's do this, round yellow to 3 round green to 3 wrinkled yellow, keep doing that, to 1 wrinkled green. So that would be the phenotype ratio because it's the physical traits. Now, for the genotype ratio, it does get a bit more complicated because there's more options. So let me move that up there. For the genotype ratio, I'll show you how this begins. I'm not going to fill the whole thing out for you. So you have to take all the different genotype options. So for example, big R, and if you look there, now that particular ratio is a 1 out of 4. Then you get big R. You get a 2 out of 4 big R, and a 1 out of 4 little r. Over here, it's similar where it's big Y is 1 out of 4. 2 out of 4 will be big Y, the heterozygous, and 1 out of 4 will be little y. So to figure out your genotype ratio, you now have to take all the different options and multiply them together. So for example, I could have big R, and big Y. My odds there, I would take my 1/4 and then multiply it by my 1/4. And I get my 1/16. I also could get big R, big Y, so 1/4, and my 2/4 option there, giving me the 3 out of 16. You would go through each option and get all the different combinations you could get, which are 9 different options you can get for your genotypes. And again, you can then take those and put them into a ratio like this, or you can leave them as the fractions. So, and as long as you're leaving the denominators all the same, those ratios will work out. So I hope that helps, and if you prefer to do the dihybrids using the FOIL method, that's an option as well. Have a great day.